Okay, hi, greeting to all Scouters. I hope you're having a great time. My name is Hollis Johnson. For 31 years I was professor of astronomy at Indiana University. I chose astronomy because I was excited about what goes on in the heavens. I might say I began studying when I was a freshman in high school. Some of you may be freshmen in high school. We had an English project to read a series of books on one subject and write a book report on them. I chose chemistry, but there weren't enough books on chemistry, so they let me put in astronomy, and I became fascinated with astronomy. And I learned all the stars and all the constellations. I loved it because I lived out on the farm where the skies were dark. Then when I went to college, I chose chemistry. But after I served my mission and was in the service, I decided to change to physics. And in the end, I've got my doctorate in astrogeophysics. So go for it, guys. Go for it. Now, so here we are, and you're now my compatriot here.
Hi, I'm Lyle Johnson, Dad's son. I grew up with Rob Samuelson. We went to Cub Scouts together and Boy Scouts together. We both earned the Eagle Scout Award. And my main qualification is I've got this NASA sweatshirt. Can you see that? This came from the Johnson Space Center in Houston. I also have owned, during the last 25 years, about 6 dozen telescopes, and I do star parties with scout groups like yours, and girls camps, and senior citizens, and college students. So I've spent a lot of time outside looking at the night sky, just like you're doing tonight, if the sky is clear.
Okay, let's start out by looking west. In the west, you will see two especially bright objects. They are both planets. The brightest is the planet Venus, and you'll notice it is very white in color. The other bright object is Jupiter, and if you compare the two, you will notice that Jupiter is a little bit not quite as bright and a little bit yellowish in color. I hope you can see that. That's important. I hope you have some sharp eyes for tonight's discussion.
Listen, I'll just add, you know, what we see in the sky is sometimes a little bit deceptive. When you look at Venus and Jupiter, it looks like those two planets are close together in the sky. Actually, Venus is coming around and is going between Earth and the Sun, and Jupiter is far, far, far on the other side of the solar system. So Venus is actually much closer to us than it is to Jupiter, even though they look like they're near each other in the sky. Okay, next we're going to turn and look at the north sky. So we've got a lot of scouts there, and I'm sure you can find your directions. I've got a map here that I'm going to show you. This comes from the internet. I printed it out and enlarged it and attached it to a piece of cardboard, but this map shows the sky exactly as it looks the night that you're out camping. The very center of the map is the point directly overhead, and then around the map you'll see west, south, east, and north. You can download a map like this at skymaps.com. There's a new map for every month of the year, and it shows you exactly what is up, and you can find anything that's in the sky at the time. So we just looked at the western sky. Now we're going to look at the northern sky. So I turned this map so the word north is at the bottom, and if you look straight up, about halfway between the horizon and the point directly above you, and just a little bit to the left, you should see the Big Dipper. The Big Dipper is turned right now so that it's standing on the end of the pan, and the two stars in the end of the Big Dipper point straight to the North Star. Now, the North Star is the very end of the handle of the Little Dipper. So we've got the Big Dipper and right next to it the Little Dipper. And if you look just a short distance to the right and below, you'll see a large W made of 5 stars. That's the constellation Cassiopeia. And if your sky is dark enough and clear enough, you'll see the Milky Way passing through Cassiopeia and winding clear across the sky to the southern horizon. See, Dad, do you want to talk about the northern sky?
No, go ahead. I'll get the east.
Okay. Okay. Now, one more thing that we might try. If you look at the handle of the Big Dipper, the star in the very center of the handle is actually a double star. And if you look carefully, you should see a very faint, tiny star right next to the brighter star. Those stars are Mizar and Alcor, and in fact, in binoculars or a telescope, one of those stars is a double star. So there are actually 3 stars there. But just with your eyes, you should be able to see the middle star and then a very faint star next to it. Many different societies throughout history have looked at those stars and used that as a test of eyesight. Okay, we are going to move to the eastern sky next, so let's all turn and face east.
Okay, east, and in the east, yes, there are no bright stars near the horizon right now. The fall constellations haven't appeared yet, but there are some beautiful ones. Of course, if you look up higher, you see the summer triangle. See if you can find 3 very bright stars constituting a triangle. And those are overhead, almost overhead, is the very bright star Vega. Look at it, find it, you'll see also it is white. It's a star, it's a hot star, and it's white in color. And it's often used as a standard. Then going to the south a little bit, you'll see another bright star. That star is Altair. Now, that's interesting. It's also a white star. Look at, is there anyone here who is 16 years of age? Because if so, the light left the star Altair when you were born. So Altair is kind of your star right now. The other star is further down and to the northeast. That star is Deneb. Now here's a good point to emphasize the difference in distance between these. Vega and Altair are relatively close to us, whereas Deneb is very far away, 1,500 light years. But it is so bright that it looks bright to us even though it's that far away. So we know right off Deneb is a very super bright star, and yet it has the same color as the other star, so it has about the same temperature. It must be a very big star. If Deneb were put where the sun is, we would all be cooked. Let's see, have we done the east? Yeah, Cygnus, I don't... Well, you might see the Northern Cross. Cygnus, Deneb, is the tip of the Northern Cross, and you might see that. It's actually called Cygnus the Swan, but most people see it just as the brighter stars form a cross. Okay, let's go to the south.
Okay, I'll just mention.
Oh, by the way, yes, and of course, Cygnus is right in it. Lyle pointed out the Milky Way. Look hard. You should be able to see the Milky Way should be quite bright, and it goes right through Cygnus. And then on south, we're going to talk about it when we get
about
to
the Milky Way?
Yeah.
Okay. All right. Let's all turn and face south. Now, if you look just above the horizon, the most prominent thing that you'll see is a line of 3 stars, almost a straight line, and the stars are about equal in brightness. That's the head of Scorpius the Scorpion. And the Scorpion winds down and to the left and back up. Now, you might have a mountain blocking the horizon, so you may not see all of this, but this is Scorpius the Scorpion. And just below the line of 3 stars, you'll see a very bright reddish star. That's Antares. If you ever see Antares and the planet Mars in the sky at the same time, you'll notice they look almost identical. Antares is a red giant and has about the same color and brightness as the planet Mars. In fact, the name Antares means rivals Mars. As you probably know, Ares and Mars are 2 different names for the same god. While we're looking at this part of the sky, if you look just above the line of 3 stars and to the right, you'll see an even brighter yellowish object, and that is the beautiful planet Saturn. Now, if we look just to the left of Scorpius the Scorpion, there's another constellation that should be easy to see just above the horizon, and that's Sagittarius. Now, I see it as a teapot with a spout and a handle and a lid. My dad says that most of his students see it as a small upside down dipper. In any case, that's the constellation Sagittarius. One interesting aspect of this constellation is, if you look just above what would be the spout of the teapot, you're looking directly at the center of the Milky Way galaxy.
What is the Milky Way galaxy? The universe is made up of galaxies. They're the basic structure of the universe. Each galaxy contains many, many stars. The Milky Way galaxy is a giant spiral galaxy. It contains, maybe 200 billion stars. Maybe more than that. It takes a long time to count them all. The galaxy is a huge flat system, flat like a dime, with a bulge in the center. When we look in the direction of Sagittarius, we're looking towards that bulge in the center. And with photography, we can see many stars, billions of stars in the center, and also dark clouds of dust and gas. That's the Milky Way galaxy. It also has these beautiful spiral arms stretching out. In fact, the Sun and its family of planets lies in one of these spiral arms. We are about 25,000 light years from the center. In other words, we're out in the suburbs of the Milky Way galaxy. The Milky Way galaxy is rotating very fast, but it's awfully big. So although the Sun and the planets are moving through space at about 250 kilometers per second, it takes us about 200 million years to orbit the Milky Way galaxy. The Milky Way galaxy is very, very large. But we see thousands, millions, billions of other galaxies. The universe is made of galaxies. Okay, so now we're ready to start. Do what?
So I thought we might talk about just quickly what a star is.
Yes.
So when we look at the night sky, we see a few objects that are part of our own solar system. So tonight we saw Venus and Jupiter, we looked at Saturn, those are part of the sun's objects. Occasionally you'll see a meteorite flash across, I should say a meteor flash across the sky. It's a meteorite once it hits the ground, but when you see it flash across the sky, it's a meteor. But with the exception of those objects, everything we see when we look at the night sky is a star in the Milky Way galaxy. There are other galaxies that we can see with binoculars or telescopes. In fact, there is one galaxy that you can see with your naked eye, but I think the horizon is probably cutting it off. So everything else that we see is a star in the Milky Way galaxy. So in a nutshell, what is a star? What makes it shine? How long does it last? Does it have a beginning and an end? In a nutshell, what is a star?
Yes, it has a beginning and an end. A star is a giant ball of gas and a little dust. Mostly hydrogen, perhaps 10% helium, and all other elements are present in very small amounts. We'll take the sun as an average star. Stars form when some cloud of gas collapses due to gravity, due to collision with another gas cloud, maybe a supernova explosion that pushes things together so that gas becomes compacted. Then it will perhaps fragment and form a whole series of stars. Stars tend to be born in clusters. Now the sun is alone, but we think it was probably born in a cluster somewhere. But the sun is so old that it's wandered so far away from its nest mates that we can't identify the other stars which formed part of that cluster. But that's the spring of a star when it's first formed. Very bright. It's surrounded by the gas and dust cloud from which it formed, but it ignites nuclear fusion in its core, and then it blows away the gas and dust by the force of both radiation pressure, that is the pressure from all the photons, and also a solar wind which blows away the gas and dust and reveals a star. We see some stars that are so new. Stars are being formed all the time. We see some stars that are so new that they still have part of that cloud of gas and dust from which they formed hanging around. But the sun is so old that all of that has long since blown away. And I might mention that now we believe that planets are formed as part of the process of star formation, because we have now seen hundreds, a few thousand planets around other stars besides the sun. So we now know that planets are formed very commonly, maybe always, when stars are formed.
Well, if we were there, we would have a question and answer session, but since we're not, thanks for letting us be part of your trip to Zion National Park. We love Zion National Park, and we hope that the rest of your trip is fantastic.
Thanks for listening. Have a great trip.